Question 6. Given the two non-zero vectors A and B, let C be the projection of A onto B. What is the projection of 10A onto 2B? Let's consider the projection of vector A onto vector B. And I've shown this with a diagram. So here is vector B, here is vector A, and vector C represents the projection of vector A onto vector B, such that a right-angled triangle is formed. Now this dotted line here represents the difference between vector A and vector C, which is vector A minus vector C. Now for the purposes of this explanation, vector A minus vector C is irrelevant. What is important though is that the direction of vector A relative to vector B remains fixed, and we're interested in what happens when vector A is increased in length. In other words, the magnitude of vector A is increased. Now we're assuming here that vector B is long enough such that the projection of vector A when it's increased in magnitude is possible onto vector B. So let's see what's happening here. We want the projection of 10 times vector A onto 2 times vector B. Now, assuming vector B is long enough or its magnitude is big enough, what happens when we increase vector A by a factor of 10? And assuming the directions are relative to each other remain fixed, if we double the magnitude of vector A, keeping the direction the same, in other words, angle theta the same, what do you think is going to happen to vector C in terms of its magnitude? If we double vector A, we double vector C in terms of its magnitude. In other words, the magnitude of vector C is directly proportional to the magnitude of vector A. So if we multiply vector A by 10, its magnitude is increased by a factor of 10, so is the magnitude of vector C. It's also increased by a factor of 10. Therefore, the projection of 10A onto 2B will be 10C. Therefore, the correct answer is option C.